In this video, we're going to look at math operations in Python, and we have those that you would expect: addition and subtraction with a plus and a minus, multiplication and division with an asterisk and a slash. We have a modulus operator that will take and do an integer division and return the remainder. We have an integer part that does the division and returns only the integer portion of that division. We can raise to a power, such as 3 squared, with the exponent or the double asterisk, and we can use parentheses to control the order of operation. Now, I've got some examples here, and first let's look at integers. And we've got 3 plus 5, 3 minus 5, and I've got a prompt here or a string saying what the math operation is, and then the actual math operation. And when I run it, I get these results. The 3 plus 5 gave me 8. The 3 minus 5 gave me minus 2. The 3 times 5, 15. All those were integers because the math operation returned an integer value. The 3 slash 5 gave us 0.6, a floating point number. The 3 slash slash 5 gave me the integer portion, and 3 divided by 5 goes 0 times with a remainder, and that's why we've got 0 here. If I were to change this to 13, I would get 2. And I didn't change my prompt, but you can see I got 2. The modulus gave me the remainder because 3 divided by 5 goes 0 times with a remainder of 3. And the 3 raised to the 5th power gave us 243. That's 3 times 3 times 3 times 3 times 3. And all that was done with integers. Now I can work with floating point numbers as well. I've got some floating point numbers. So 3.2 and 5.8 for all of them. And I've done the same operations. And here I get 3.2 plus 5.8 is 9.0. It's a floating point number. 3.2 minus 5.82 minus 2.59, all those. What's going on there? Well, the 3.2 times 5.8 gave us what we would expect, but the division also gave me an unexpected number. These really long numbers are due to rounding because of the way those numbers are actually stored. They're stored in an IEEE format for floating point numbers, and so there are rounding errors. And in this case, it generated, instead of the minus 2.6 that we expected, the 0.59999s. And the same thing with the division here. Instead of, I guess, 0.55, it gave us the 0.551. The floor gave us the 0 we would have expected. So we have the ability to do floating point math. Now, had we mixed integers and floating point numbers, we would have gotten a return of a floating point number. Now, I've also got a couple of more that we're going to look at. And here I've got 3 plus 5 times 3 and 3 times 5 plus 3. When I run those, I get 18. The order of operations is important, and multiplication and division are always done before addition and subtraction. And had there been more than one multiplication and division, addition and subtraction, it would have gone left to right. So here even though the addition was first, it did the multiplication, gave us 15, plus 3 gave us the 18. And here the multiplication is first, still gives us 15 plus the 3. Well, what if I wanted the addition to come first? Well, I can do that by using parentheses. And by putting the 3 plus 5 in parentheses, it tells the computer, do the addition first. And when we run this now, we get 24. It took and added the 3 plus 5 to give us 8 and multiplied that by 3. If you have multiple layers of parentheses inside of parentheses, it will do the innermost first and work its way out. So we can control that operation. If there's any doubt in the order it's going to be performed, use the parentheses to force the order. Now, if you're enjoying these videos, please like and subscribe.